Hello there. Having gone through z-scores, how to calculate them, and how to go from a z-score back into the corresponding raw score, it's time that we move beyond looking at z's for individual values and start looking at the z-scores for a group. So when we're talking about a z-score for a group, we're no longer dealing with the exact same formulas. They're similar, but they're a little bit different. And this is because groups vary less than individuals. And so instead of using our normal formula, let's go ahead and put that in black, using our normal formula. So if we had z is equal to x minus mu over the standard deviation, that's our, quote unquote, individual. When it comes time to look at groups, we instead use z is equal to x bar minus mu over this term. This term is called the standard deviation of the sampling distribution, but is far more often referred to as the standard error of the mean, which is what I will be referring to it as from here on out. So before we can calculate the z-score for groups, we need to look at how to calculate this standard error of the mean. We'll go ahead and box that off, grab another color, and head off. So when we're talking about our standard error of the mean, we know that it's equal to here. And this makes sense because the full name, the standard deviation of the sampling distribution, well, this symbol right here, sigma, lowercase sigma rather, is what our symbol that's commonly used for a standard deviation. And then x bar is used to refer to the mean of a sample. So you can use that to help you remember where this set of symbols comes from. Now for our formula. The formula for the standard error of the mean is equal to our standard deviation over the square root of n. So let's go ahead and calculate this out. Grab this, and then we'll head on over with some black, and we'll walk through the steps. So first, we're going to have to pull in our numbers. When we were talking about this earlier, we calculated that mu was equal to 7, n was equal to 6, and standard deviation is equal to 3.7. So that should be all that we need to know. It also points out just how much of the analysis we do builds off of the work we've already done. That oftentimes when you're going through and calculating things, you calculate a whole bunch of these individual formulas together to get to where you want to end up. So first step, adding in our numbers. So we're going to have 3.7 over the square root of 6. Go this way. Step 2. For step 2, we're going to have to bring in our calculator. We're going to take 6, find our square root. So that gives us 2.45 with rounding rules because of the 9 there. And that is under the 3.7. Now let's go on to step 3. Step 3, we just have to divide. So we have the 3.7 divided by 2.45 is equal to 1.51. Rest of the digits have to drop because of rounding rules. And so there we go. That gives us the standard error of the mean. And we can now compare this group to another group. Now, since you are already familiar with how to calculate this for another group, I'm going to skip over that. And we're just going to go ahead and make up some interesting numbers for our next group. So when calculating our z for groups, we already said we needed z is equal to x bar minus mu over our standard error of the mean. Well, we already know that mu is equal to 7 and that our standard error of the mean is equal to 1.51. So we can get something, I don't know, exciting out of this. Let's go with something that's a fair bit larger than this. Let's go with 11. Let's say we had a mu of 11, or rather an x bar of 11. So that's step 1. We head over here for step 2. We're going to see that we end up with 4 over 1.51. And we'll just go ahead and go down. For step 3, which gives us 4 divided by 1.51 is equal to 2.65 with our rounding. And there you have it. That is how you calculate a z-score for a group. If you needed to find a specific raw score for a z-score, that would be the same process that we already talked about in our video on how to do it for individual values. So you can go back and check that formula if you need it. I hope that this has been helpful for you, that you'll let me know if there's anything that you're particularly interested in learning about next. And as always, you'll be able to find this down in the description.